Hello viewers and my subscribers. You are welcome to Understanding Chemistry by Nkechi. Today's topic, let's look at fractional half-life of a reaction. I have already done video on rates of chemical reaction, factors that affect rate of chemical reaction, orders of reaction ranging from 0, first and second, and how the unit of how one can easily derive the unit of rate constant, and also graphical representation of 0 order, first and the second order. So it's good to watch that video before this one. All right. Let's look at fractional half-life of a reaction. What does it mean? It's the time it will take a certain fraction of the concentration of reactant present to go to product. So among the fractional half-life of reaction, the one that is common among them is half-life. So use T subscript half to represent it. So other fractional half-life include 2/3, 3/4, and so on and so forth. So let's look at the meaning of half-life. What does it mean? Half-life is the time taken for the half of the concentration of the reactant present to go to product. That's what it means. Then to 3/4 half-life, what does it mean? 3/4 half-life. 3/4 life simply means the time it will take 3/4 of the concentration of the reactant present to go to product. What of 2/3 life? The time it will take 2/3 of the concentration of the reactant present to go to product. So we're looking at half-life. That's what we're considering now. Okay, let's look at we want to look at 0 order, half-life of 0 order, first and second. Okay, for 0 order reaction, this formula for 0 order. So I already done video on calculation, how to use this formula to do calculation. If you have to find T and then maybe this final concentration or the one at time, we already done that video on that. So look at this. So the 0 order reaction, for 0 order reaction, let me put here. For 0 order reaction, so the half-life for 0 order reaction is equals to initial concentration all over 2 times rate constant. So this is the final concentration. This is initial concentration. K is rate constant or specific rate constant. So what does it mean? So it means that half-life increases as half-life is directly proportional to initial concentration. So half-life increases as initial concentration increases. Half-life is inversely proportional to the rate constant. So which means as half-life increases, rate constant decreases because they are inversely proportional. Okay, let's look at first order reaction. For first order reaction, so this formula log concentration at time minus K over 2.303 plus log of initial concentration. So this is the formula for first order reaction. So the half-life for first order is ln 2 over K. So if you punch ln 2 in your calculator, it will give you approximately 0.693 all over K. So what it means that half-life is independent of initial concentration, but it's inversely proportional to rate constant. So as half-life increases, rate constant or decreases. Okay, look at this. This half-life. So we'll talk about half-life. What does it mean, the half-life in general, half-life? It simply means the time it will take. For example, if you start with 1 molar concentration of hydrogen peroxide, for instance, 1 molar concentration of hydrogen peroxide. So it means that the time it will take this concentration, which is 1, to reduce to half of it, to reduce to 0.5 molar concentration. That's what it means by half-life. The time it will take 0.5 molar concentration to reduce to 0.25. and so on and so forth. That's what half-life simply means. Okay. So for this first order reaction, which is independent of initial concentration, what it means that the time it will take 1 molar concentration of hydrogen peroxide to reduce to 0.5 molar concentration is the same time it will also take 0.5 molar concentration to reduce to 0.25. The time it will take 2 molar concentration of hydrogen peroxide, 2 mole, to reduce to 1. In the same time, it will take 1 molar concentration of hydrogen peroxide to reduce to 0.5. Okay. So let's look at second order reaction. Second order. For second order. Half-life. For second order. Half-life for second order reaction is 1 over K times initial concentration. So you can see half-life is inversely proportional to rate constant. Half-life also inversely proportional to initial concentration. So as half-life increases, rate constant decreases. As half-life increases, initial concentration decreases because they are inversely proportional to one another. So we'll be solving some exercises on half-life. So remember this equation. Let me write the equation for second order because we'll still need it. So inverse of final concentration minus KT plus 1 over initial concentration. Okay, so if the half-life for a first order reaction in B is 3 minutes, how long will it take concentration of B to reach 25% of the initial concentration? How long will it take the concentration of B to reach 25% of the initial concentration? Okay, look at this. So since we are given the half-life to be 3 minutes, so we can use the formula of half-life to get rate constant. Okay, so solution. So the formula for half-life for first order reaction is 0.693 all in 2 over K. So we are given over K. We are given half-life to be 3. So making K sort of formula 0.693. So what's half-life? Half-life is 3 minutes. So when you divide this, you'll be having 0.231. What should be the unit? The unit will be what? Per minute. Very important. Per minute. Per minute. Good. So since we have run on K, we're going to use the formula of first order reaction. Formula of first order reaction, which is log of the concentration at time equals to minus KT over 2.303 plus log of initial concentration. Okay? Okay, look at this. How long will it take the concentration of B to reach 25% of the initial concentration? So here, this concentration, how long will it, this one is the concentration at time, the one at time. How long will it take concentration of B to reach 25%? So 25% is the concentration at time, which is this one, the one at time is 25%. So how long will it take? Which the original one is what? 100%, which is the initial concentration is 100%. So this one is the concentration at time. How long will it take the concentration of B to reach 25%? So it's good to note all this is very important. Okay, so we're going to put a formula. So log, the one at time is 25%, 25 minus what's K? So K is 0.231 times T all over 2.303 plus log 100.
Log 25 is 1.398. Is equals to. So when this divide this, you have minus 0.1003 t plus log 100 is 2. So I'm going to bring this to this side. The negative sign will cancel. So it will now be 0.1003 t is equals to 2 minus 1.398. So you make this out of formula. We're having this minus this. You have 0.602 divided by 0.1003. So the value of t will be 6. You can have 6.00. So the value is 6 minutes. So 6 minutes. So it means that if you take 6 minutes of concentration of B to reach 25% of the initial concentration. Okay. Let's see the question number 2. A reaction was found to occur at a rate of 2.39 times 10 raised to the power minus 3 per second. Calculate the half-life of the reaction. Number 2, the time taken for the concentration to drop 1/3 of the initial concentration. Okay, look at this. We are not giving the order of the reaction, whether it's first order or second or third order. But we are told, look at the unit of rate constant. So you can use the unit of rate constant to know the order, to determine the order of the reaction. So since this one is per seconds, so that is first order reaction. So the previous video have done how to find the rate constant, the easy way to find the unit. So let me just repeat it here. So this M represents, that's molar concentration, mole per dmq or mole per liter. So 1 minus N per time is constant. So it can be per seconds, it can be per hour, per day. So let me use per seconds. Time is constant. So this N signifies order of reaction. So order of reaction. So if it's first order reaction, it will be 1 minus 1. So that is 0. Anything raised to the power 0 is anything as what? 1. So you are left with what? Per seconds. So it's a first order reaction. So put the formula for half-life for the first order reaction. 0.69 or lim 2 divided by K. So since we are giving the rate constant is 2 points. K is 2.39 times 10 raised to the power minus 3 per seconds. So the value of T, half-life, is going to be 290 seconds. 290 seconds. So that is the answer. 290 seconds. So the question number 3, we are looking for the time taken for the concentration to drop 1/3 of the initial concentration. So say the same thing. So the time taken for the concentration to drop 1/3. So this 1/3 is the concentration for the one at time. Initial concentration is 100, then this one might be 1/3 of 100. So the question number 2. So I'm going to put the formula for. So for question number 2, initial concentration 100. Concentration at time. The time taken for the concentration to drop 1/3 of the initial concentration. So the initial concentration is 100. So 1/3 of initial concentration will give you the one at time. That's at 3.3. So we're going to put the formula. Log concentration at time is equals to minus KT. What about 2.303 plus log? It's good to know this formula. Know it very well. So log, I want to the value, log 33.3 is equals to minus, what's the value for K? K is 2.39 times 10. Raised to the power minus 3. T plus, okay, let me do this one, all over 2.303 plus, what's the log of initial concentration? Log 100. So right. So log 33.3 will give us 0.5224. So because when you evaluate this value, divide this, you're having minus 1.03778 times 10 raised to the power minus 3 t plus log 100 is 2. So if you bring this value to this side, you'll be having 1.03778 times 10 raised to the power minus 3. It is equals to 2 minus 0.5224. So t, the value of t will be, when you subtract this value, you have 1.776 divided by 1.03778 times 10 raised to the power minus 3. So the answer you will get is 460 seconds. So that's the answer. The answer is 460 seconds. Okay. So another person can also solve his or her own by making this t sort of formula straight. Making this t sort of formula. If you have to make the t sort of formula, what we'll have is t is equals to. So the formula you obtain is t is equals to 2.303 all over k times log initial concentration divided by log of the concentration at time. So if you want to make this sort of formula straight, this formula I'm going to use, the negative sign will no longer be there. This formula to use and get it. Let us consider question number 3. The half-life of methyl mercury in the body is 6.05 times 10 raised to the power 6 seconds. If 0.05 mole per liter of the compound was accidentally swallowed, how many days will it take for this poisonous compound to decrease to 0.01 mole per liter in the body? Relative decay is a first order reaction. Take note of that. Any relative decay is what? A first order reaction. So solution 0.69, which is something as ln 2 divided by k. So k is going to be, we are given the half-life 0.693. So the half-life is 6.05 times 10 raised to the power 6 seconds. And that's about 6 seconds. So the value is 1.14 times 10 raised to the power minus 7 per second. So having found the rate constant, we are going to use the formula of first order reaction to find how many days. Good. The time we are going to get when we will use, since I did not convert this time to days yet, I want to convert it at the end. The time I'm going to get will be in seconds. Then from there, we'll convert it to what? To days. If you also want to convert this one straight to days, before you start using, you still get the same answer. So log of the initial concentration of the one at time minus kt over 2.303 plus log of initial concentration. So I'm going to substitute the value of this into this equation. So the value for concentration at time is 0.01. So log 0.01 is equals to minus, what's the value for k? So the value for k is 1.14 times 10 raised to the power minus 7 t divided by 2.303 plus log of initial concentration, we have it to be 0.05. So this value, log 0.01 will give you minus 3 is equals to, when you divide this, you obtain minus 4. So when you divide this, you're going to obtain minus 4.95 times 10 raised to the power minus 8. So log 0.05 is minus 1.3. So then there's a plus here. Plus times minus will give minus. So have minus 1.3. So I'm going to bring this value here. Minus 4.9 cross the equality sign becomes plus 4.95 times 10 to the power minus 8t is equals to. So minus 1.3. This 3 minus 3 cross the equality sign becomes plus 3. So the value of t will be 1.7 over 1.95. 1.95. So we're going to have 3, 4, 3, 4, 3, 4, 3, 4 seconds. So this answer, we're going to have the answer in days. So we're going to convert that seconds to days. So T in days. 3.34, 34 seconds. So what's the unit conversion? How many minutes make 1 second? So 1 minute is equals to 60 seconds times hour to minute. 1 hour is equals to 60, equivalent to 60 minutes times. So 1 hour is equals to 60 minutes. The what of a relationship between hour and days. So 1 day is equal to what? 24 hours. So I'll put day up. 1 day is equivalent to what? 24 hours. So I'm going to 34 seconds divided by 60 times 60 times 24. So I'm going to have, so T is going to be, so the value is going to be 397 days. 397 days. Okay. So just know how to do your unit conversion. This minute will cancel minutes, hour will cancel hour, seconds will cancel seconds. You will be left with days. So that's the answer. We'll come to the end of today's lesson. Subscribe to this channel. If you're not subscribe. I'll get appreciated. And your comment will be highly appreciated. Your comments. Comment on this video. Share it so that you get more people. Thank you for watching and do have a great day. Bye.